Hello, sixth graders. Before you do anything, I just want you to follow along with the video. You don't need to write any of this down. So in A, it says this: find a blue rectangle that is similar to the red rectangle and has one side from -1, -6 to 5, -6. And that's already labeled right here. Label the vertices. And then it says check to make sure these two rectangles are similar by showing that their ratios of corresponding sides are equal. So let's make a similar rectangle. We see here that this length is 3. We see that we have to make a side length here of, let's see, 1, 2, 3, 4, 5, 6. That means what's the ratio of sides? Well, here we go. Ratio of length, 3. Blue length, 6. Therefore, that simplifies into 1/2. Well, this length is 1, 2, 3, 4, 5, 6. So what would the length of the big rectangle be? Well, if it's a half, it's going to be 12, and you know that. So 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if we make our rectangle, it looks like that. Now what do we know? Change in y. Change in y over change in y. So change in y, that's 6/12. Change in x, that's 3/6. They're equal. So yes, these are similar. And we'll move this up. So the rectangles are similar. However, we're going to go one step further here. I'm going to move this over. Let's compare perimeters and area. Now we've actually done volume and surface area, so this goes along the lines with that. You know that the ratio of dimensions in surface area, the surface area is squared, whatever the ratio is. Volume, you cube the ratio. So the perimeter. On your own, just find the perimeter of the red and the blue. So write those down. Well, the red perimeter is 18 units. The blue perimeter is 1, 2, 3, let's see, 6 and 12. That was 18, so it'd be 36. What was the ratio of the side lengths? The ratio of the side lengths was 1/2. What's the ratio of the perimeter? It's 18/36, which is 1/2. So what conjecture can you make from the perimeters? Your conjecture is going to be that the perimeter of the shapes is equal to the ratio of their corresponding sides. What about the red area? Well, the red area is going to be 18 squared units. Blue is going to be what? Well, 6 times 12, 72 squared units. The ratio here, 18 divided by 72, simplifies into what fraction? It's 1/4. So how do you go here? Look what I do. I square it. If I take 1/2 times 1/2, you get 1/4. That's why it's area. You square it. Which leads into what we're doing in this section. We're going to talk about perimeter and areas of similar figures. So here's key idea number 1. Perimeter. Please, please, please don't forget this. The perimeter of one triangle, in this case the red triangle, triangle ABC to triangle DEF, that means I can take the ratio of any of the sides. The length of AB to DE, BC to EF, AC to DF, they're all equal. The perimeters are equal to the ratio of their corresponding side lengths. So we're going to start off with number 1. Find the ratio of red to blue of the perimeter of the similar rectangles. Well, red to blue is 4/6. 4/6 simplifies into 2/3. That means the ratio of the perimeters will be 2/3. Now, if I went one step further and I said, well, find the perimeter. Let's say the perimeter here was 28. Find the perimeter of the big blue rectangle. Well, you would do this. 2/3 is the ratio of the side lengths. Equals 28 over x. They're equal, so I can set them equal to each other. So I would get 2x equals 28 multiplied by 3, which gives us 2x equals 84, which gives me 42. So the perimeter of the blue rectangle would be 42. The next key idea talks about when you have two similar figures, the ratio of their areas is each of the corresponding side lengths, the ratio, squared. So you're going to take the ratio of any of the side lengths and square them. And that would give us the ratio of the areas. So in example 2, find the ratio of red to blue of the areas of the similar triangles. Well, it's 6/10, piece of cake, but I have to square it. So that gives me 3/5 squared, which gives me a ratio of 9/25. So if I told you that the area of the, let's say the blue one was 100. That's the area, square units. Then you would take 6/10 squared or 3/5 squared or just 9/25 and you would write a proportion. You don't take the proportion 3/5. You square it and that would give me 25x equals 900. And 900 divided by 25 gives me 36. So the area of the blue would be 36 square units. In example 3, we're going to talk about a swimming pool and a volleyball court that are both similar in shape. Find the perimeter and area of the pool. So I need to find the perimeter and the area. Well, the first thing I need to do is write a ratio of the side lengths that are corresponding. As you can see, 18 and 10 are the widths. Therefore, I can write them as a ratio of either 18/10 or 10/18. I'm just going to do 10/18. Simplify that. Well, 10/18 is going to simplify into what? 5/9. Good. Now, the perimeter ratios are the same as the side length ratios. So I can do 5/9. Well, the perimeter is 60 yards of the volleyball court. Well, this was the volleyball court. So I do 60 over x. Take the cross products. 5x equals what? It'd be 540. 540 divided by x gives me 108. Therefore, the perimeter is 108 yards of the pool. Now the area, all I have to do is take that 5/9 again, but you have to square it because the ratio of the side length squared is equal to the ratio of the areas. So the ratio of the areas would be 200 over x. So that gives me 25 over 81 equals 200 divided by x. Cross products, 25x equals, 16,200 divided by 25. And the area is going to be 648 square yards. In this section, there's no new vocabulary that you would need to make note of.